Yeah, so hello everyone. Thank you for joining, and thank you very much, Dr. Khadijeh Fathalikhani, for accepting our invitation and agreeing to give this interesting talk. So, Dr. Khadija is an independent AI researcher and has a PhD in mathematics. So, we look forward to your talk, and please start when you are ready.
Okay, thank you very much for the introduction. Hello, everyone. That's a great pleasure for me to be here and share this information with you. And thanks for Dr. Wajid for his invitation. As I told you, a great pleasure for me. My name is Khadijeh Fathalikhani. I have a PhD in mathematics and then made a transition to AI and data analytics world. Let me talk about my background a bit. I have studied graph theory, combinatories, and finite group theory. I have published several research papers. I have presented at international conferences, and I've been visiting researcher in Spain and Slovenia, and have had university level teaching and different courses like calculus, analysis, and programming, and the other courses. But recently, I was quite interested in the world of AI, artificial intelligence, and data analytics. And I remember that the first course that I passed in data analytics, it was quite interesting for me. After passing something like about 20 years in mathematics, I got familiar with the world of artificial intelligence. And believe it or not, I could not realize how time was passing. It was very enjoyable for me. I could see the application of mathematics there and really interesting. And now here I want to talk to you about data analytics, machine learning, artificial intelligence systems, and AI agents. But these are actually I don't want to go to the details. These are actually an introduction. Yes, as I told you, not heavy technical details, just an introduction about these topics. And what is data analytics? Excuse me, sorry. Data analytics, it is examining raw data to extract insights, patterns, and knowledge. This is actually data-driven decision making. We make decision according to data. And nowadays, even in a small supermarket, you need data analytics because you make decision according to your data. And let me explain more. Why data analytics matters? Uh, First of all, finding bottlenecks. When you analyze historical data, you find the bottlenecks of your system, where and find a place where the system is slow. And when you find a place, then you go and fix the problem, and don't let your system to be crashed just because of a small weakness in your system. And a very important is the resource optimization. Want to make a balance between cost and performance. It is since that many companies over provision their resources, the servers, just due to the fear of system downtime. And in most cases, more than 80% of capacity is empty just because of their fear. And data analytics helps us to make a cost performance trade-off. Another reason that data analytics matters is discovering hidden patterns. When you have data and you discover your data, you find some hidden patterns that without analyzing data, you will not understand it at all. For example, you may understand that customers who buy product A are interested to buying product B. And so you recommend product B to people who buy product I, or in your supermarket, you put product B inside the product A to encourage them to buy it. Also, data analytics helps us to actually to predict future outcomes. Demand forecasting. About demand forecasting, let me tell you that, for example, uh, as I told you, when you find a problem in your system, you will go and fix the problem. Imagine you by analyzing your data, you see that your database grows up about 10 gigabytes every month. Then you will understand when you will run out of your storage, and then you go instead of emergency purchase, you go and budget and buy your actually upgrade your system in the needed time. And about the data analytics workflow, first of all, you need to data collect. You need to collect your data. So I want to small this window here. That's okay now. About data collection, first of all, you need to collect your data. We have several ways of collecting data. You may do surveys, you may do interviews, observations, experiments, and digital collection. These are primary data, and we have secondary data also. This means that you do not collect your data the data by yourself. You go to the library and websites of the other, you use actually the other data. But the difference is that when you do the collecting data by yourself in the primary data collecting, it takes you time and cost. You have to spend a lot of time and cost to do actually collecting. But in the secondary data, you don't need to spend that much. But the difference is that in the secondary data, you don't know how the data is collected, and you don't have any choice unless trusting the people, trusting the data. While in this primary data, you know the process. Although in the secondary data, sometimes you see that the data that you have gathered, you have collected, you have actually obtained is not answering your questions well. And so you need to do some surveys by yourself, or need to ask for another data source also. After collecting your data, you need data pre-processing. As I told you, sometimes you see that the data we have here is not enough. It's not going to answer our questions. So we need data integration. We need to collect, ask another data source to make it in a way that it can answer our questions. And data cleaning, then we need to clean our data. Imagine in a kitchen, it is a kitchen of data. You have raw data, you have raw ingredient. You cannot put the raw ingredient straightly into the pot. You need to clean your data, clean the ingredients. Now we need to clean our data. What do we mean by cleaning the data? It means that for example, you may see that you have duplicates. So you clean the duplicate, and you may see that you have some dictation errors. You should fix the problems, fix the dictation errors here. Sometimes you see outlier data. For example, the age of the person is written 500, so it should be 50. or you see that some missing values you have, the age is not written. This is the data cleaning process. Then you need to data transformation. Like the ingredient, after cleaning the ingredient, you need to chop it to be in the form that is suitable for the pot. And now we have denser transformation. For example, the format of the date. You see that we have different kinds of formats. And now we make them all in the same format. Or for example, fail, female and male. We put zero or one for all of them. We make them in a, or normalization. Sometimes you need to put all the numbers, something between zero and one. And then data reduction. Sometimes you see that your data is very, very huge data and you cannot do your calculation well. You may omit some of the data. This is data pre-processing. Then you go to very important part, exploratory data analysis. We have univariate. Sometimes, first of all, you try when you start your analysis, you see at the variables. You see, you may have univariate analysis, bivariate, or multivariate. Univariate means that you look at each variable separately, its average, its minimum, its maximum, and whatever you may consider. And then bivariate may help you a lot. How this variable will affect on the other one. A multivariate analysis, maybe you want to analyze and see the effect of four or five variables on the other parameter feature here. It helps you very much. Sometimes you can find very nice patterns during this analysis. Outlier detection and missing patterns. As I told you, this can be considered as pre-processing. But what I want to tell you here is to be careful about these two parts because sometimes you should be always ask yourself that why I should what should I do with the outlier and missing patterns. Imagine that in your database you have asked about the national identity number of the people. You see that some people have not filled this part. And if you miss this information and or put some numbers instead or do anything with these missing patterns, you will lose very useful information. Maybe by investigating more, you understand that these people are those who are foreigners and they don't have national identity number, they don't have any national identity card. And so this gives you a good group of people that you can analyze and see their behavior. And if you put some numbers in these missing patterns, you will lose this good information. And about outlier detection, be careful that when you see the outlier number, you should not immediately omit that number or write something instead. Maybe this information, this number is giving you very useful information. For example, the temperature is very high. Maybe it gives you the information that something is going, it is wrong here. I want to tell you that about these two parts, you should be careful. Then we have feature relationship. We need to investigate the relationship of the features. This is very important. If you do not consider this part, your calculations and model will be in most cases wrong. Because, for example, we have correlation matrix. The correlation matrix shows us that relationship between features. It shows you if the correlation between two features is one or very near to one, it shows that when one goes up, the other goes up exactly the same amount. So we don't need these two features to be in our calculation. We omit one of them. Okay, and this is very important part. And in your calculation, you will see that if you do not consider the correlation and multicollinearity, your calculation will be, you will counter some problems. And then after doing that pre-processing, these EDA, yeah, we have modeling and analysis. We have different models. In machine learning, we have regression, we have classification, clustering, time theories, dimension reduction, optimization. These are different models that we have. For example, we choose these models according to what we are going to find. For example, regression, when we want to investigate and find the number, a continuous number, we go to regression. When we want to make a classification, which class our data is belonging to, then we go to classification and the other, according to what we are going to find, we choose our model. Then we go to visualization. After doing all of these heavy processing, heavy analysis, visualization and communication is very important. How to show the results to the user. It is very important. It does not mean to just make pretty pictures. Pretty pictures is good, but it is to show the results, your results to your user just in a few seconds. That's a bridge between your heavy calculations and the decision making procedure. We may use bar chart, line chart, composition, and communication. You should be able to communicate and explain. We need some simplifications. You do not need to show all the details, just simplification. What you think that is very important. Also, I want to show you, point the interactive dashboard. It is very nice tool because it helps the user to what we say, slice and dice the data. Uh, the user can talk to the data. The user, instead of just looking at some rigid script, the user can filter the data and see the results according to what it is for more interested to him. And types of data analytics. We have descriptives. This tells us what happened, just like a dashboard of a car. The dashboard shows you the fuel, the dashboard just tells you the speed. It doesn't tell you the reason, just tells you what is happening, what happened. And then we have diagnostic. Why did it happen? It gives us the information that we know what happened, but this stage tells us the reason. And then predictive, what is likely to happen, and then prescriptive, what should we do? We have data analytics tools. For data foundation, we need different softwares like SQL is very, very important to actually store and manage our large database. For analysis, we have Python, R, and Excel. For visualization, Tableau, Power BI, these are very famous ones. And for advanced analytics, we have TensorFlow and PyTorch. PyTorch. What is the application of data analytics in healthcare and medicine? In healthcare and medicine, it helps doctors to actually, what we say, instead of treating everyone the same, it is personalized medicine. They give treatment according to each person. Let me talk about one of our paper. We actually made a model which by asking the which giving by when we give the model the information of the patient, for example, the age, sex, um, the other factors of the heart, I don't know, blood pressure, and the other things, the model gives us if the person is in the high risk of a heart attack or not. And it is useful because sometimes you do not access to the doctors, but be careful that the model should be very precise. Imagine what will happen if the person is really in the danger of heart attack and the model says, no, no, that's okay, you can go. So I want to tell you in the other slides, I will explain that here what we have is probability. And what we try to do is to calculate, is to make our model very powerful, near to the probability should be near to 1. And then about the smart cities, it has very application in smart cities. By sensors and GPS, we can manage it and adjust the time, traffic light timing. Or we can recognize the high risk zone for accident. About banking, we can detect fraud detection. We may see that some transactions are actually over. It is not usual, so it can be fraud, and we can see if the person is reliable to give the loan or not. About e-commerce, it helps us, the system, the recommendation system. You see that in Amazon and the other digital marketing, you have recommendation system. It gives you recommendation according to what you have bought. Of course, we have two kinds of recommendation. First, first of all, the first is about what you have bought previously, and second is about what people like you have bought and what the other people who have the same personality as you have bought. About the sport and entertainment, there are some wearable GPS that the heart rate of the player can be identified, and so if any injuries may occur, it can be prevented. Now let's go to machine learning. Machine learning is a subfield of artificial intelligence. Artificial intelligence is, in general, means that the mind can, computer systems can think like human. But machine learning means that you actually let system to learn. System learns by itself. Let's see the difference between programming, traditional programming, and machine learning. In traditional programming, we give data and rule to computer and ask it for output. What does it mean? For example, we want to ask, um, tell the computer that which email should be considered as a spam and which email should be considered not a spam. And we say some codes. If you see the word winner in your email, then mark it as a spam. This is the rule we give it. And then we give a data. We give a new email to computer. Then it gives us output to consider if it spam or not. Imagine what will happen that how many lines of code you need to write to exactly tell the computer which email should be considered as a spam and which email should not be considered as a spam, because just telling that the winner is not enough. You know that a lot of emails may not actually have the word winner, but they are spam. So you should consider all possibilities, and tell the computer and write a lot of if then rules. But in machine learning, what happens in machine learning? In machine learning, we give lots of examples to computer. Output, we give it output. We give 10, for example, 10,000 emails labeled as a spam and 10,000 emails labeled as not a spam. And computer will understand itself how to uh, identify every email as a spam or not a spam. It is inspired by how human thinks. Imagine that you want to learn your child what is dog and cat. You do not say that if it has this kind of, I don't know, ear, this is cat. If it is the mouse is here, this is cat. You do not explain your child like this. You give it a lot of examples. This is cat. This is dog. This is cat. This is dog. Then the child will understand how to identify cat from dog. And this is exactly what we do here for computers, just giving the examples, a lot of examples we give to the computer, and it gives and it follows the rule by itself. Mathematical foundations of ML. First of all, linear algebra. When we say data, imagine that we want to calculate, we want to estimate the price of a house. We need several actually features. The age of a house, its a square meter, it's the number of bedrooms, the color of the I don't know, bathroom, and the other things. These are actually the data we have. When we talk about data, we are actually talking about a point in feature space. See, a point in a feature space, and to in algebra, vectors and matrices is a way to actually hold the data. So we need linear algebra here. And then probability and statistics. As I told you, what we have is just probability. We don't have our model. Don't give you the answer which are 100% sure. When you ask it if it is spam or not, you know that it may make a mistake that um, identify a real email to be a spam. I mean that we should not trust on the models 100%. But probability helps us to calculate how confident we are on the calculations. And statistics, this is also important because when we know the distribution of our data and how the data is spread out, we can understand which model will be more suitable for this, for the results that we want. Calculation. Calculus is very important. I will explain also data, but let me tell you that um, we want to calculate and shorten the error as much as possible. What, for example, you want to calculate the price of the house. The real price of the house is 500 for $500, and your estimation is $300. So you have $200 mistake error here, and it is actually too much error. And what you need is to minimize this error as much as possible. So you have loss function here, and you want to minimize this loss function. So you need calculations, you need gradients, and the other concepts of calculation. I want to tell you that mathematics is very important in the world of AI and data analytics and the other things. And graph theory is also very important. You put nodes, whatever you want to calculate, whatever you want to consider, and to find the relationship between them, and the relations between them. You draw a line as an age for the relations between them. Graph theory is also very important for the um, for ML. We have different kinds of machine learning. We have supervised learning. When we say supervised, it means that you have a supervision, you have supervisor, you have a teacher. But it means that supervised learning means that your data have label. For example, you have lots of pictures of banana and apple. You have written it is banana, it is apple, it is banana, it is apple. They have labels. If they have labels, if your data have label, so it is considered as supervised learning. And regression is under supervised learning classification. As I told you, you give your model lots of pictures of dogs and cats. This is dog, this is cat, this is dog, cat, dog, cat. So these have labels, and then suddenly you give it a new picture. Give, tell me, is if it is dog or cat, then the model will understand how to identify this picture. These are supervised learning. When we say unsupervised, it means that we have raw data, we have a lot of data here, but not without label. We don't have label here. And the model is said that find some pattern here in this mess. Clustering. Clustering is unsupervised learning. It feels some pattern that these two are the same, have the same behavior, this have the same behavior, this have the same behavior. This is called clustering. And dimensional reduction also by nature is unsupervised learning. We have reinforcement learning that it is inspired by how humans and animals learn from rewards and punishment. The agent takes action in the environment. If it has done the good job, then there is a reward. If the bad job, it has wrong, then penalty. The agent will understand how to maximize the rewards, and this is trial and error learning. But in general, how model learn? First of all, guess. When we say model, at beginning it is a mathematical structure without no knowledge. It doesn't know anything, just a mathematical structure. But then it has some weights, some parameters it have that it should be found. At first, at the beginning, it is just guess without no knowledge. So then we go and find the loss function, how much error it by this guess, how much error we made. If it is too much, then we are not satisfied and we go and do the adjustment. In the adjustment, actually, here the model is learning. It means that it is adjusting the weights. The weights should be found in a way that error to minimize the error. And the repetition is very important because not one, two, three, millions and millions times may we need repetition to get to the success. Uh, as I told you, we have loss function. We want to minimize the loss, the error that we have made. We want to minimize this. See, minimize this. Imagine that you are in a foggy mountain. You are in a foggy mountain and you don't see the bottom of the valley. When I said that we have a function, loss function, and we want to minimize it, I mean that we want to go to the bottom of the valley. But as I told you, the model is mathematical structure with no knowledge. So imagine that you are in a foggy mountain and you want to go to the bottom of the valley, but you don't see the bottom. But you can feel the slope under your feet. So you choose the slope that goes downward, and gradually you go downward. Yes. The how big your steps are is actually is important. It is called learning rate. This your step, how big your steps are is called learning rate. If your learning rate is too much here, your learning rate is too much, you may jump over the valley. Your learning rate is too big and you may jump over the valley. If your learning rate is too small, it may take forever to go to the bottom of the valley. So, not this one, not this one. Learning rate is very important. How to choose the good learning rate to go to the bottom of the valley. Here is our success. We have made minimum error here. Okay, now neural network. Network is inspired by our brain. It's inside our brain. We have 86 billion, I don't know, a lot of uh, cells called neuron. And neural networks is actually inspired by the biological neuron. What is biological neuron? It has this structure. These are dendrites. These are receivers. They receive signals from the neighbors. This is soma, the central part. This sums up all the signals, and we have axon here that is a cable to carry the signal to the end of the neuron. Here, between two neurons, between this one and the neighbor, there is a small gap here called synapse. Here, the learning happens. If this signal, if the neuron fires, it means that it's going to send the signal to the neighbor. And if it sends the signal to the neighbor, then learning happens. Now, it is the structure of the biological Maya. We have the same thing by mathematical neuron. These are inputs, x1 to x5 here. How we fit the model. And we consider weight for them. It's giving the importance of each input. Imagine in the calculation of and estimating the price of the house, the color of the bathroom is not important. So we choose very low actually weight for that feature, but the number of bedrooms is very important factor, so high importance, high amount of weight for this one. So we these are the weights, and we also consider a bias. Bias is a number that helps the model to have more flexibility. If we do not consider bias, then the model will be just independent of just to be dependent of the inputs x1 to xn. And imagine that x1 and xn, all of them are zero, then your value will be zero. So bias gives the flexibility to your model. See, weights give the changes the slope, and bias changes the line vertically, horizontally. So it goes to the soma here. The summation happens here. And then we need function, activation function. Without activation function, we actually doesn't have anything, just some simple calculations. But activation function helps system to be non-linear, and so very important decision making will happen. Activation function, and the result is here. But what is activation function? We have different kind of functions, but the most important ones is sigmoid and relu. Sigmoid has some problems. You see, it squashes values between 0 and 1. So it is very good for the probability outputs, but it have vanishing gradient problem. It is the problem. What does it means? The gradient of this, if you derivative of this you calculate the derivative of sigmoid, you see that its maximum value occurs at x 0 and it is 0.25. So by multiplying 0.25 for many times, it goes towards 0 and it is vanishing. So in this some cases you see that some after some layers, some you see that it is 0 and no learning is happening. I mean that it doesn't let your model uh, to make the ways better. So the best suggestion is Relu. Nowadays, Relu is more actually more used by the scientists in the models because first of all it is very simple and fast, and it doesn't have vanishing gradient. Gradient is also it's all the time one, so it does not go to vanish. And very important thing is that it is sparse activation. It means that, see here, sometimes it has zero amount, sometimes one. And so the neurons are not always all of them talking as simultaneously. When the neurons all this talking, some mess will happen. But in real, sometimes some of them are quiet, some of them are speaking, and so better decision making will happen. um, Perceptron. I just want to mention perceptron to see the difference. Perceptron is the actually um, its activation is function is step function. The first actually the first mathematical neuron that is made by the scientists it was perceptron, choosing step function as the activation function. But uh, afterwards, the scientists decided to choose ReLU. Step function has just 0 and 1, so it has only two outputs, 0 or 1, and it can be used for boundary decisions that which make decision between two cases, dog, cat. It, it cannot help us to make complicated decisions. But when you use ReLU, it gives you some other numbers also, not just 0, not just two numbers. It gives you the other numbers also. And so it helps you to make more complicated decisions. Neural networks, this is made of many, see how many neurons here we have. All of them are mathematical neurons here. And we have an input layer, output layer. Here it's one just, we have just one hidden layer. But when the number of hidden layers goes up, here we have three layers, but in complicated, in deep learning, we have more than three layers. That helps us to understand and manipulate some sophisticated, complicated, for example, like mm, uh, recognizing the pictures, the face of the person. This is very complicated feature, task that can be done by deep learning. The key application of neuron networks is the computer vision, that the picture of the person, the picture of the animals can be identified uh, by within a picture or video. Or you know that in your headphone and your system, it can just understand your identify your face by looking at your face. uh, the language processing NLP, it can help you to talk to you. It can understand your human talks. And for finance it can several applications. Fraud detection can be done. And market, like as I explained you in recommendation systems that we have in Amazon and the other online marketing, in autonomous system, the cars that run or self-driving vehicles, and also it helps us to identify the areas that are in high risk, and it has several applications. Here, I want to show you that what we see here is this, and what computer sees is this. And just I wanted to show you the picture, that the difference between what we see and what computer sees. And large language models, LLMs, are actually a type of artificial intelligence that are trained to manipulate and understand human language. Of course, I'm sure that you have used most of them: Gemini, Cloud, ChatGPT. You have used them, and you see that they can do everything. They can answer your questions like a human. They can write an essay for you, write email for you. They can solve mathematical problems. They can do programming for you, coding for you. They can do everything for you. And here, see, artificial uh, intelligence is the big concept. And then machine learning is here, deep learning is here, it is generative AI, and then large language model, LLMs, are here. Why they are large? Because they are trained on trillions of words of books, of essays, articles, websites, and that's why this is called large language models, and they can do everything. Now, the last part is the AI agents. Actually, these are beyond prediction. AI agents, what we have, large language models are the reasoning agents here. What we had so far was just, for example, in large language model, you ask question and it answers you. But in the AI agents, they do, they action. These are actually digital employee for you. When you give it a task, it do planning, decision making, autonomous action. For example, I ask it to write an essay for me. Give it a title and ask it to write an essay for me. It do planning. It actually breaks down the title into manageable subtitles. It actually breaks the task, the huge task, to smaller tasks. It divides the title is this, and it makes some subtitles, and then it has the power of decision making. It does not just following, waiting for someone to clicking. It makes decision, because LLM is the reasoning engine, is the brain here, and it makes decision that for each title what should be written here. And then it has autonomous action, it has hands. It is not waiting for anyone to do anything. It has access to the APIs, it has access to the web browsers and the other things, and have access to the email and sends you email and it has hands, can do anything that you ask it. It has memory, as I told you. The LLM is the brain here. The LLM is the brain here, but it needs memory to remember what is done previously and what is going to do in the next steps, and then planning. And it of course needs tools like APIs, code, web search, and the other tools that may be needed. And here is my workflow that I have made in N8N. I have I gave it a topic and asked it to actually write an essay for me. See here, this is the N8A is it start with chat trigger. I write something here, a topic. I have written AL now. AI. Of course, the title is wrong, but LLM understands itself that the right word is AI. AI and different methods of teaching. This is what I give it. And see, it goes to the other part. Here, LLM divides the topic into 5 subjects, and then here is the brain here. It decides what topics should be done. The essays is going to choose here, and that's why it takes more time. We wait until the process is doing. See here, we have used LLM twice. The first one for dividing to 5 subtitles, and the other one for, see, it is done. The previous, finished. And now it is going to send me an email. I go to my email. It gives me an email that because I asked it to send me an email, and this is the essay that it has produced for me. Subtitles and conclusion, and also the references. Okay. Here, I brought you a picture that how mathematics is important for the future of AI. See, the picture tells you everything that from mathematics, AI is powering intelligent systems. Has no choice because mathematics gives it power. And final message. See, AI is moving from telling to doing, as I told you. And now, as students, mathematics trains exactly the skills AI needs. As students of mathematics, you might wonder how your current studies translate to this new field. The truth is, a mathematical background is one of the strongest foundations you can have. Mathematics isn't just about solving equations. It is about training the brain to solve complex problems. The same rigor you use in a proof is the foundation for understanding how learning algorithms and neural networks actually function. Your training gives you the mental toolbox required to innovate in AI. Logic, abstraction, and structure remain essential, while specific AI tools and frameworks change every few months. The core principles remain constant. Logic is the backbone of how agents reason and make decisions. Abstraction allows us to take a complex real world problem and turn it into a model that a machine can understand. The structure is necessary to organize data and build scalable systems. These are exactly the strengths of a mathematician, and they are more essential now than ever before. Thank you very much.
Thank you very much, Khadija, for that excellent talk. Um, yeah, a lot of things. You covered a lot of things, and we might have some questions. I think we already have 2 questions in the chat.